All right, so my name's Elaine Palmer. I work for IBM's research division. I'm based out of Yorktown Heights, New York. I work in a security research group. And let's see, you're good? Okay, and Eric from Samsung.
Yeah, my name is Eric Hibbard. I'm with Samsung. I work in the product planning division, dealing with SSDs and NAND technology. But relative to probably this talk, I actually represent the U.S. on international cybersecurity and privacy standards, and equivalent within IEEE. I chair the Cybersecurity and Privacy Standards Committee, so watching lots of activities, including crypto.
Super. All right, let's see. So the things that we're going to go through today are, there's a new security section added to the hardware template. I'm sorry, I can't see you, but anyway, hardware template. We want to talk about how do you use it to specify due diligence and requirements in your products, and differentiation so that you can show that you are better than your competitors. And then how standards will help you to write these specifications, and some guidance document that Eric will talk about. All right, so first, how many of you think that an OCP product should clearly identify its security features? Good set. How many of you have to navigate multiple international security standards with your global products? Yeah, another concern. So the work that Eric and I will present today is work that's coming out of the OCP security project. And it was developed over several years. It came about, we were trying to make security requirements that were mandated, and that didn't go over very well with some of the OCP vendors. So instead, what we thought we'd do is help the vendors and the customers by adding a new section, section 18, to the OCP's hardware specification template. It became effective on April Fool's Day. It wasn't a joke, it was real. And it includes what your product will require and recommend. On features that are recommended, then it includes a required by date. So for example, if you want to, in the future, have quantum safe digital signature protection, you would put that in there and say by when you wanted it. It's a template. It's to help you. It's not to mandate that you must do all of these things. So you can omit what's in the draft template, and you can add things that are missing that you need to emphasize. So why did we even do this in the first place? So those of you who are security geeks like we are know that you have to build security in from the beginning. You can't glue it on. It can't be a sidecar hanging off the side. You can't add it after the product's done. It just doesn't work that way. So we want to make sure that the products that are being presented and offered through OCP have already thought about security from the design from the very beginning. So why the due diligence and the differentiator? So the due diligence part is what's required now. What is the bare minimum that you provide, that this product must provide when it is built? What's the minimum? And it's required now if you are to comply with the specification. Acceptable is a little bit different. It means it's required now, but you might have a choice of different alternatives. Like for digital signature algorithm, you might allow them to choose RSA 2048 or 4096 or elliptic curve algorithms. It's still required. They have to make a choice. And recommended is really a future statement, which says, we'd like you to do this now if you can, but even if you can't, we would expect it to be implemented by a certain date, and you provide the date. The recommended is where we typically would see the differentiator. So due diligence would be the minimum. Differentiator are things that you add above that in your spec that are recommended. So let's start with the template itself. So if your product uses cryptography, key derivation, key generation, key agreement protocols, hashing, you should identify any of the algorithms that you are going to require, what modes they should operate in, what strength, RSA 2048, RSA 4096, and how it should be used. If you require compliance with any national or international standards, which Eric's going to talk about, you should identify it there in your spec. Now, when you get to entropy or random number generators or key generators, what are the acceptable sources of entropy? Will you get it from a keyboard? Will you get it from say a ring oscillator? Where do you expect the entropy to come from? Because a lot of security problems originate in poor random number generators. If you require certification, which certification do you need for your algorithms? Your certifications can include just the algorithms to make sure that they've been implemented correctly and adequately tested, or they can go even broader, which is cryptographic modules on this recommended list here. And do you require that they even have cryptographic module certification? And if your product is going to require someday protections against quantum computer attacks, then you need to say so, and by when. For secure boot and attestation, you would require identify the required flow of your secure boot starting from the very first electron when hardware reset starts, all the way up through the firmware. What is that flow? And if you require any attestation protocols, this is where you would identify those. There's a section on supply chain and lifecycle management. There you would identify what are the acceptable environments for provisioning keys and secrets and seeds. In some devices will allow the device to get those injected, or we call it squirted in the TPM world. Others will require that the key be, or seed or secret be generated within the device itself and never ever leave the device and not come from the outside. So whatever you require, this is where you would document that. Surely there will be vulnerabilities in the firmware at some point, hopefully not in the hardware, but if there are vulnerabilities, what's your process for identifying those vulnerabilities and distributing field updates to address them? And if you're using secure boot, what is your key lifecycle management? When do you revoke keys? Do you just hope that they never are compromised? For secure boot, there's a key, of course, to verify the incoming firmware. For attestation, there's a key to sign the outgoing attestations. How are you handling those keys? There are also standards emerging on software bills of material and firmware recovery mechanisms. What would you recommend in those? So it's only a template. This is not, it's mandated that Section 8 be there, but you decide what's in it. If it's very sparse, it might look funny that your product doesn't have much in security features, but it can also be very rich. It's up to you. And you would decide what's in the required box, what's in the acceptable box, and what's recommended. or what's omitted. You don't have to do this on your own out of whole cloth. There is already one accepted product that has already included a Section 18. It's the Hyperscale NVMe Boot SSD spec, version 1. It has a very rich Section 18. It's a good model to follow, and it's a real product. On top of that, you don't have to operate blind. There are other examples in the security project documents, in the secure boot document, the attestation. There's a common security threats document, and another document on secure firmware development best practices. So you're not in the dark there. And I'm going to hand this over to Eric now.
Thanks, Elaine.
Yep.
So I'm going to pick up from the point of, right now there's a security section in the template, and that's great. And we've seen an example with the boot spec where they've actually gone in and specified the security to address what's in that template. However, watching that activity, it became relatively clear that that could be a very painful process for, and I see some head bobbing on this, it could be a very painful process for the groups, the projects that don't have a crypto background. And it's actually very easy to get this wrong. Bigger problem, how do you maintain it? Because as attacks occur and whatnot, you need to deal with that. So from an OCP security project perspective, we believe we need to go one step beyond that. And we're on the cusp of releasing a document. I'll go into a little more detail. But one of the key thoughts is how do we deal with the international work in crypto, which is if you track that space, you want to be as aligned, in my opinion, and I'm biased because I represent the US at the international level, you want to be careful to select cryptography that's going to be acceptable around the world. There are some instances where that can be challenging. For example, if you're dealing with China and Russia, for example, they're not necessarily too thrilled about crypto that may have originated in some form in the US. But in general, the international community has selected a range of ciphers and modes and hashing algorithms that have been specified. They have been carefully selected from potentially a pool of, there might have been 10 options, and they will have selected maybe one or two. They don't want to standardize all of those. But what happens in the international community, you have this sort of focus on a handful of algorithms and whatnot. So from a OCP perspective, we want to take advantage of that kind of work, where there's been a convergence on some number of standards. And as long as it doesn't get us sideways with our major customer base, it's ideal to kind of use those. Right? So the advantage of tracking this is that as the threat landscape changes, as the regulatory landscape changes, ISO, for example, does make adjustments to its standards. And I can tell you over the last 2 weeks, the ISO committee was meeting. They've started work on post-quantum crypto, finally. But they've been monitoring it for 6 or 7 years. So we're now seeing some progress. So we're anticipating in the not too distant future, there'll be actually an ISO standard that will cover this. I'm sure NIST and comparable US players will be heavily engaged. I can actually attest to that. I already see them operating in the US side. So if we align our OCP crypto on some of these standards, it may actually make it relatively straightforward to sell our products internationally because you're using this. An example is AES. Well, if you're used to the NIST version of that, you'll cite a particular document, but there's actually an ISO equivalent. And as long as you know that, you can speak to both of them and your problem is basically solved. So we're seeing that alignment with these standards will help with the due diligence, due care kinds of situations. it'll allow us to not necessarily actively track what's happening with the various landscapes. We can follow their lead. Having visibility into the process, because it takes about 3 years for an ISO standard. It's not like we're going to be ambushed. We can actually see what's coming, potentially participate in it. There are those of us that are plugged into these kind of activities, right? So how does this help customers? Well, in many cases, customers are being driven to, they have a certain risk tolerance, and these standards are going to help them deal with that. The fact that they're selected ISO standards, it's hard for certain litigious jurisdictions to assert that that would not be a reasonable activity to undertake. As somebody who operates in the American Bar Association and watching lawyers, you want to have a solid foundation that you're basing things like your crypto and your security on. It also helps with interoperability, hopefully certifications as well, and it's pretty easy to demonstrate compliance when you've got international standards and you can point at those and say, this is how we did that. The challenge, and especially for those of us who operate in the United States, we've got a combination of domestic standards, for example, NIST. We've got international standards, like some of the ISO, ITUT, IEEE standards you're having to deal with. And then there are an assortment of sort of industry activities. Because standards don't necessarily, especially at the ISO level, cover every aspect of it. It may, for example, define the algorithm, but it doesn't necessarily tell you how to implement it or how to use it correctly, things of that nature. So we do have to sort of work across sort of multiple layers in the standard and specification space. Okay, so with all that, how can we in the OCP security project potentially help with this situation? Well, one of the ways is actually to develop some fairly focused specifications, like a crypto specification that lays out sort of chapter and verse of certain algorithms, certain key strengths, other considerations that need to be factored into this. Single document, and if you're writing specifications in OCP, you could actually cite that as a requirement. And so part of the checklist that Elaine was just talking about, you get to check the box because you've basically, if you're a C programmer, included the requirements in the crypto specification. All right, so the other advantage of doing that is over time, as the crypto needs to be adjusted, we can update the crypto spec to reflect what changes need to be accounted for. And those automatically, you have the ability in your specifications to then either adopt those or not. We've also seen that, at least at this point in time, crypto is not crypto. We actually are aware of two different sets of requirements that are not perfectly aligned. And so in the crypto specification that's been drafted, we actually have baseline crypto, which roughly speaking tracks on the kinds of requirements we see from NIST. So if you're worried about things like FIPS 140 certifications, then you would be very interested in those. And there's another set that are more closely aligned with what we're seeing as guidance from the NSA. So it's basically a step up in terms of strengths in certain algorithms. But you can't necessarily get those FIPS 140 certified because they're not necessarily the approved algorithms or strengths. So, however, in our conversations, it turns out that there's a desire that we don't care about FIPS 140, we want the stronger security. And so the way we've dealt with this in the specification is we actually have baseline and enhanced. And that gives us the ability to do that. And so why is this important? Well, in your specifications, you could cite the cryptography specification that meets the crypto part of the template, and you say baseline or enhanced. And again, you've now selected a range of algorithms and strengths and everything else. Point being, this is intended to make it easy for spec writers in OCP to get the right language without having to go and do the kind of research that Elaine and I do, tracking all these standards. And to give you an idea, in the case of the ISO committee that I'm involved with, it's ISO SE27. It's actually ISO IEC JTC1 SE27. There are 325 documents, either published, core agenda, amendments, or drafts. You probably don't want to be looking at all those. That's part of my day job, to manage the US kind of position on those. So you have people like Elaine and I who are focused on what's in those, how do they relate, and you can take advantage of that work. This is a sort of a trial balloon, if you will, to see how well this works. If it does work, some of the other elements that are identified in the specification, the template, we may be able to actually do something similar to that. So for example, if you're worrying about vulnerability management, there's actually a whole set of standards around that. NIST has some, ISO has some of those, and some of that could probably be brought to bear. So there's some consistency in terms of how you deal with those. So I think, depending on how this first spec is received, you could see more of these to kind of help. So the end goal is to improve the overall security of not only the specification, but the products that claim conformance with those, whatever that means. Okay, so agree, disagree? We want you to get involved. We want to hear your voice. We want to, as a vendor, does this help you? Does this hurt you? As somebody who's involved in writing specs, somebody who is, hyperscalers, is this the kind of thing that you want to see more of? From a security perspective, we think some of this modular approach may be useful. You're not forced to use it. It's a tool to basically help you. And so here's some of the contact information. OCP project meets on Tuesdays, 11:30 Eastern, 8:30 Pacific, like me. Come join, lots of interesting conversations. Even though it's early, it's usually pretty lively. Elaine, any other comments?
None for me, no.
Okay. Questions, comments?
If you have questions, please use one of the mics because it's all being recorded.
Well, we know it's really early and, security in the morning. it's a.
Oh, yes. So the question is, in a situation where the specification may require, for example, SHA-384 versus what's sort of commonly used, in maybe SHA-256, how do you reconcile that? This is an example. In fact, this is actually one of the areas that we've seen differences between. For example, sort of NIST and FIPS 140 kind of scenario versus maybe an NSA-focused kind of scenario. And from the crypto spec perspective, the way we dealt with it is we just acknowledged that those two basically existed and give the choice of the spec writer as to kind of which of those scenarios they require. We also anticipate that at some point we may have to add a third category as we get closer to post-quantum kinds of scenarios where those become mandatory. So it really is going to come down to when the spec is being written as to which option is mandated. So now the challenge is if
if the spec makes a choice like you just stated, and FIPS 140 is also a requirement, and they don't align, then this is an area where, from a security project perspective, we may have to offer some feedback as you can't have both of these. That these are mutually exclusive kind of scenarios, and this is part of the challenge, is to be aware of those kinds of situations. It's also a possibility that we may be aware that there are changes coming to the standards, like in the case of FIPS 140, that may ultimately bring them back into alignment. But right now we are definitely aware that there's the NIST versus NSA sort of minimum requirements are not perfectly aligned. So we acknowledge that. We just make sure that you understand, if you select the NSA piece, good or bad, it may preclude you from getting a FIPS 140 certification, or actually the ISO 19790. There's actually 2 ISO standards that NIST uses, and then they do a partial replacement of some of the crypto. Now, we know that the 2 ISO standards that NIST is pointing at are both under revision as of last week. So stay tuned. It's going to be fluid. And it's by design, we're trying to basically make it easy to deal with that fluidity. So long-winded explanation, but hopefully that. Okay.
Yeah. So I think, you had one question, and then we'll be out of time. So yes. Oh, it's not on. Oh, now it is.
Okay. Yes. So just now, Microsoft has open sourced RTL for the Cleopatra, root of trust in silicon, and also Hydra. So I mean, do we suggest, or the OCP's point of view, instead of every organization trying to reinvent the wheel, reinvent the exact same thing, we just absorb that into our silicon IP? And I mean, do we know if they also offer the RTL code for the crypto accelerators, AES engines, and all?
So I saw the announcements. I've previously seen drafts. I'm looking forward to actually reviewing I guess it's the .5 version of the specification. And I can tell you from my own personal experience, and I did this with the SSD boot spec, I am more than happy to provide feedback if I think that there may be some challenges or some issues there. Now, how those get handled is a different matter. But yeah, given the announcement and the interest, yeah, we will definitely be looking at
Brian Kelly's in the audience. Brian, are you presenting today? Okay.
So I'm fond of giving documents. We call it love.
All right. That's it. We need. Oh, Brian. Yeah. Yeah. All right. Okay. So thank you very much for your attention.